Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Uh, Hope so you are all doing well. And today I will talk about the shear force bending moment and its diagram. And we can determine these values from a numerical. It's a structure numerical where we have to evaluate the reaction forces like fx and fy and moments and shear force and bending moment. So here we just draw the diagram of a beam where the loads actually applied. So here we just draw the particular diagram here. So then we can just start it out the whole numerical. So here the horizontal line you can see here the in the blackboard is a you can see the beam, and the vertical load applied on it, and its name is a C. So I just put it the second one load that is on the starting area of the beam. So here we just applied the vertical load on the beam towards downward, and here you can see, and its name is B. So we will write the names of beam like ABC after draw the diagram. So here we can just resize the its size and put it the names here. Here you can see the name, the vertical load, it's a C point, and here you can see it's a B point as I already said. So because we just give the name, so it's easiness for us. So I just put it a color here, and its name is B. So you can see here it's a beam, and vertical loads applied on it, and it's a point, and there is also a sports like hinge sport and roller sport, like as a triangle shape and a circle shape. We just draw here the sports on the A and D point, and put that sports into the relevant spots. So I just figure out its and names, and put the relevant shapes to their spots, and we can just start it out. A, and here it's a D point, and the vertical loads that I drawn here, it's different loads that applied on a beam, uh, and it's a first one, it is a 15 kilonewton here, and the second one and load that applied on a beam that is vertically downward, that is a 20 kilonewton 20 kilonewton load that applied vertically on the beam. So you can see there is a two loads, point loads, it's called point load, that applied on a B point and C point. So here we just put the two shapes, that is a uh, roller and a hinge sport, and the distance between these points is a here 2 meter from point A to point B. You can see here the 2 meter distance from point A to point B, and then we can just write the The second one, distance B to C is a 3 meter, and the third one is a from point C to D is a 2 meter. You can see here. So here you can see its loads, point loads, and its distances and its points. It's like A, B, C, and D. So here, as I said earlier about the sports like hinge sports, that is a triangle shape. It's a hinge sport. I just put it into the A point, and the second one I just set it out its spot into the relevant spot. So then we're moving towards draw the uh, fourth sport, that is a roller sport, and we just put it as a hinge sport, and we just draw the roller sport here on the point D. You can see here the point D. We just draw a dot here and expand its size and just put it into the D point, because it's a roller sport, and its shape is a round shape, and you can see it's a four sport, two sports, that is a one is a hinge sport, second is a roller sport, and 2 point loads applied on a vertical beam. One is a 15 kilonewton, second one is a 20 kilonewton. So that is a whole diagram. We have to find its reaction forces and its moments, reaction force and shear force, and bending moment of these points, and also we have to draw on the shear force diagram and bending moment diagram respectively. So we just start with the reaction forces. Fx is equal to 0, and as conversely is a Fy is equal to 0. So Fx, that is a horizontal forces, and Fy, it's a vertical forces, like the point loads that applied on a beam, and vertical loads that applied through the hinge sport, like hinge sport and roller sports. Okay, and we just try it out. You can understand easily. So hope so you understand the point of view which I meant to say. So here we just started it out through the it's a reaction RA and RD, because it's from the A point and it's from for the D point. It's named as RA and RD. So we just start with the Fy, because we don't have a Fx forces or horizontal forces here. So we just start from the Fy is equal to 0. Okay, and here we just write it down the positive forces first, like Ra plus Rd. Okay, and minus point load, like 15 kilonewton, and minus 20 kilonewton is equal to 0. So here you can see the four forces that applied on that particular beam. So we just find it out the reaction forces Ra and Rd. How we can evaluate? You can see here, Ra plus Rd and minus 35 is equal to 0, and we just find the one value of Ra or Rd. Then we can evaluate the second one. So how we can evaluate the one value? We can evaluate from the it from its movements. We just start its movements, how we can and then get the value from it of reaction forces. So here you can see the reaction forces that I divided down. So here we just start with the movements. Some of the movements, that is m a is equal to 0. Okay, so here we just put it the e sign. You can see here is a sum of the sign is a something relevant to that e point. Because I don't know about the sign in my keyboard, that's why I put it the e here. So basically I meant to say here the sum of movements ma is equal to 0. So here you can see how we can evaluate the main thing. Okay, and we just start with the 15 multiplied by 2 plus 20 multiplied by 5 and minus rd is multiplied by 7 is equal to 0. Here you can see how we write it down. The r is equal to 0, and 15 multiplied by 2 and 20 multiplied by 5, the distance, because we have to count from all the point loads or the sports towards the point A. Okay, and rd values here, and we put it that all the values, write it down, and is it, you can we find the actual value from here. rd value is equal to is a 18.57. Here we got the value from here. Okay, that's the point of view that I want to say here. rd value is equal to 18.57, and we just put the value into the equation that we write here. Ra plus rd value is 18.57 minus 35 is equal to 0. So here we got the ra value from here. Ra minus 16.43, ra is equal to 16.43, the actual value of ra. Reaction of on a point A is equal to 16.43. Okay, we got the two values. So now we are moving toward the shear forces. As I said earlier, how we can evaluate the shear forces. So here you can see the shear force. It's what is the shear force? Shear force is the sum of the forces that applied on a beam. It's a upward and downward. It's all about it. The shear force, which I will evaluate here in a few seconds more. So I just put the title here, and then we can start the shear forces of point A, B, C, and D respectively. So we just write the shear force to point A, because we moving towards point to point, because we have to find the shear forces of point A, B, and C. So shear force at point A is 16.43, because I already find the value RA, because it's a vertical force. As I already said, it's a sum of forces that applied on a beam, vertical forces. So the point A is equal to 16.43, and shear force at point B is equal to, we have to minus or plus the value of vertical forces or load that applied on a beam, 16.43, and point A is like we have to is a 15 kilonewton. It's downward and it's a minus sign, negative sign. So we have to write it down and calculate it here. 16.43 minus 15 is equal to 1.43 here. So the third one, shear force at point C. What's the next thing that applied on a point C is equal to 1.43 here, minus or plus. It's a minus because 20 kilonewton applied on a beam downward. It's a minus 20 is equal to 20 minus 1.43, and we got the 18.57 value. The last one is a shear force at the point D. The we got the continuous value minus 18.57, and we go already find out the RD value. It's a plus one because it's going upward. Minus 18.57 plus 18.57 is equal to 0. The most important thing you have to remind in your mind, the if your answer at the last point is 0, then your shear forces is correct. If your answer at the last point is some 5, 10, or anything else, your answer is incorrect. You have to be in your mind the one thing which I want to say. So we are moving toward the Earth's shear force diagram by seeing the values and to evaluate the process like shear force at the point A, B, and C and D. The values we got, and we have to apply it on a diagram here. We just write down its title here, then we moving towards its diagram, so you can understand easily. It's not a big issue. Additionally, I want to say, just I draw a beam, and A, B, C, and 4 D point. It's a 4 point, and here you can see the diagram, and it's the values of shear forces. And what's the point A shear force value is 16.43. As you can see, 16.43, it's a upward, it's a positive point. uh, when you can see the positive points or plus points is a upward, and negative point is a downward, because forces are applied on downward direction. So 16.43, second one is a 1.43. We got the shear force value, so we draw on the diagram 1.43 value. And moving toward the C point, what the shear force value we got, it's I think minus 18.57. We just see here, and minus 18.57 we just applied on a diagram. Minus 18.57, it's a downward minus toward minus, and we just draw into and connect with the 0, because last point is a 0. As I already said, if your answer is at the last point is 0, your shear force is numerical or process is correct, and you have to do it by seeing this numerical. So there are the points where we applied the shear forces, and the values. A point is of 16.43 is a positive, and B point is a, I think, 1.43, because we moving toward lower points. We just drawn and write here by to understand easily. And I just write the values which we evaluate in the previous slide, and the C point, we got the minus 18.57, and we just write it here, the actual value, and moving to the D point, which is a 0. And that is a shear force diagram. You can understand easily how we can evaluate and write the shear force diagram. It's a positive and it's also a positive section, and the third one, which is from C to D, it's in the negative, from the lower downward, and it's a minus sign. We just draw here minus sign. That's the whole picture or diagram of SFD, shear force diagram. Now we're moving toward the bending moment. How we can calculate the moments at point A, B, C, D separately. As we evaluate the shear force, the we just have to evaluate the bending moment. What is a bending moment? Bending moment is a multiplication of the point load to by its distance from the point we started. So we just write the from point A, point bending moment at point A is 0 because there is no distance. We have RA, and if we have RA and we have no distance, so RA multiplied by 0 is equal to 0. Bending moment at point B. B point, if we're starting from RA is value is 16.43 and multiply by 2, and we just write it on that area. You can just understand easily. RD value is equal to 18.57. So RA value 16.43 multiplied by 2, and the next one, the point load applied, if we write here, the 15 multiplied by 0 is equal to 0. So we are moving toward C. We have to calculate the moment from A towards C until C. So 16.43 RA value multiply by the distance from A to C, that is a 5. Now we write the B point, point load, minus 15 multiply by 3. You can understand right now. So we just calculate these values. That is a whole values of bending moment at point C. Bending moment at point D is 18.57, and we just start from RA towards the point RD. So 16.43 multiply by 7 minus 15 multiply by 5 minus 20 multiply by 2 is equal to 0. Okay, you can see, I just calculate here, and that is a 0. So that is a bending moment diagram. Bending moment uh, values, we just write it down. Hope so you can understand here easily. If you have still any question, you just write it on the comment section. I will answer it accordingly. So we are moving towards its BMD, bending moment diagram. I just write down its title and draw its lines, and then we will draw the BMD diagram. We just draw the diagram. You that clarity of a beam or a picture that everyone can understand. And it's a professional thing, and you will cost it in the future when you have in a corporate sector or any other um, office. So here, I just draw the line which is called a beam, and here I just pointed out the dots, that is the points A, B, C, and D for your easiness. Then we draw the BMD we got from the these values. And here is a picture of a beam, and we got the bending moment values from that picture, that diagram, and that numerical. And from A point we have movement is a 0, and B point we have a movement like 32.86. We just draw it's a positive, and to the C point it's a little bit higher, and we just draw toward the C, it's a 37.15. And moving toward the D, we just draw toward the 0, and it's a downward. So here you can see its picture, and we just draw it's a section scenario. I just put it the line that you can see easily, and it's all in the positive section, and its a sign is a plus. I just put it down so you can understand easily. And it's a value on A point, it is a 0, and is a B point, it's a 32.86, and third one is a 37.15, and fourth one is a 0. Here there is a 4 points ABC, and so I just draw the positive signs here, and that is a point, it's a B point, and this is a C point, and that is a D point. So you can see the whole picture of PMD and its values. So that is the whole numerical. I just evaluate the values, reaction, firstly reactions, and then movements, and then we got the shear force and its diagram, and then bending moment and its diagram. These are the four things we got from that numerical, so you can easily get the knowledge from it. And if you have still a question, so you can put it out in the comment section. I will answer it accordingly. That is the structure numerical of shear force bending moment. So if you got my points, so please like and share and subscribe Civil Technology Talk for the further guidance and these numerical. Also you can understand. I will also put the clear picture of BMD and its values and the numerical in the last of this video. So if you have any questions, so write here, and I suggest you please see the next video that is related to a structure numerical. You can get the knowledge from it. I will post it in the description. So that's the snaps. So thanks for watching. Allah Hafiz.